Welcome back, everybody. We're going to finish our 3.0A notes on factoring today. And we're talking about special cases. So we know that our typical form for quadratics is ax squared plus bx plus c. So what happens if they ask us to factor x squared minus 36? So we have two choices for this. We can start with rewriting this in standard form above. We have the x squared and we have the c. We're missing the middle term. So if we're missing a middle term that's not there, then we can fill it in as 0x and then factor just as we did on the last set of notes. There's no common factor that I can pull out. So 1 times negative 36 is negative 36. The factors of negative 36 that add to 0 are going to be 6 and negative 6. So bring down x squared plus 6x minus 6x and bring down the 36. Split it in half. Our common factor on the left side is x. X squared divided by x is x, plus 6x divided by x is 6. We start the next side with the subtraction, and the common factor between 6 and 36 is 6. Negative 6x divided by negative 6 is x, and negative 36 divided by negative 6 is positive 6. So here's our two sets of parentheses that are exactly the same. And so x plus 6 is one of our factors. And then the x minus 6 that we pulled out is our other factors. So is there a shortcut to this? Of course there is. These two things are called a difference of perfect squares. A difference of perfect squares only has two terms. They are missing the b term. That's that middle term that we added as a 0x on the other slide. Both terms are perfect squares. And then there is a subtraction sign in the middle, a difference, subtraction. So x squared is a perfect square, 36 is a perfect square. They're perfect squares because we can take the square root and not get a negative or a decimal answer. So the shortcut is to take the square root of each term. Now notice I didn't put the subtraction underneath the radical. And I make two sets of parentheses. So the square root of x squared is x. We write 1x in either set of parentheses. The square root of 36 is 6. One's plus, one's minus. And that is our factor. So if I try the other examples, we have x squared minus 16. Perfect squares, subtraction, only two terms. So the square root of x squared is x. The square root of 16 is 4. One's plus, one's minus. 4d squared minus 81. 4 is a perfect square. D squared is a perfect square. 81 is a perfect square. There's only two terms, and we have our subtraction here. So we square root each term. write our sets of parentheses. The square root of 4 is 2. The square root of d squared is d. The square root of 81 is 9. 1's plus, 1's minus. No, it doesn't matter which parenthesis we put the plus and which parenthesis we put the minus. The next one, we have 25t squared minus 121. Take the square root of 25, and we get 5. The square root of t squared is t. The square root of 121 is 11. 1's plus, 1's minus. 225 f squared minus 49. Square root of 225 is 15. F square root of 49 is 7. 1's plus, 1's minus. So the last question asks, why can't we use this process? Sorry about that. W squared for w squared plus 9. And so this is what I want you to think about. Try some factoring on this and bring this into class tomorrow to start our discussion. Have a great night.